Okay, so here we go again with AWK. Whoops, that's not the one I wanted. I want to get a new window. So we go to System Tools, LX Terminal. All right. Let me shrink down this window a bit and get started. Okay, so we had looked at some stuff with arrays last time, okay? Now, a lot of the things that we do with AWK are line by line, right? Where you just go through and you deal with whatever you have in a data file, line by line, similarly to SED. Sometimes, though, you want to have all of the information that you're interested in dealing with, sorting through, organizing all at once. And so using arrays can help us to do that. And one of the things that we can do with AWK is we can define arrays where the indices, the tags that we use to organize the data, like you could think of it as this big, a big lineup of cubbies, okay, where you can put them all, these are boxes where you can put values, right? And they're all in a line, okay? And so if you have a set of cubbies, you can say, great, I'm going to label these as 1, 2, 3, 4, 5, for example, okay? Or you could use names to specify each of the cubbies, okay? So we've already looked at an example where we specified using indices that were numerical, but we don't have to do that. So for example, let's look at one where that's not the case, all right? So for example, let's go with AWK, okay? And we're going to do something with begin, right? Now you remember how this works. Begin means I'm doing something before I go through whatever file it is that I want to work with, okay? Now in this case, we may not be working with a file at all. Let's just go ahead and put in some commands, okay? This is where we're going to specify an array. We say colors, okay? And then in this bracket, I'm going to put the index, okay? So I'm putting the index in like that. And I'm going to put the contents, basically what I'm putting inside the cubby here is going to be red, okay? And then I'm going to put a semicolon because I want to specify another one. Colors, this time I want it to be G, okay? And I so happens that I want to put this in as green. Okay, it doesn't have to be, right? I'm just saying this is how I'm labeling these things, okay? And then I have one more, colors. This one is going to be B. And I'm going to let this equal blue, okay? So that's what I've set up to begin things, okay? So I'm setting up this array, specifying the values here. I've specified that I have 3 spots in this array, and these are the contents, okay? And then I put another semicolon in because I want to do something else, okay? I want to say for, have a for loop, okay? For, and then this is interesting. Okay. Key in colors. This is something, a structure I haven't used before. Okay, this is more advanced. All right. This allows you to go through. I mean, there's no order here, right? We don't have numbers. It's not like we're iterating through indices where you say for 1 to 3, print out the values, right? It's just pick the key. Okay, the key. So we want to print. Whoops. Sorry. Yes. Print. Key, comma, okay, and then a colon, okay, and then another comma, colors, and then key, okay. And so we close out the print statement, and then we close out what we're doing for begin, okay. And that's all we're going to do. Everything's being done in begin, which is unusual, okay? And that should work. Notice I didn't specify a file at all, right? Because if you look at this code, let me go back up to it, right? With AWK, you have the option of putting in begin and then saying, okay, right after the begin, in curly braces, I'm enclosing some stuff that I want to do before I go through a file line by line. All right? And what am I doing? I'm setting up an array, and then I'm printing out the contents of the array. And then I'm done, because I'm not really interested in doing anything else, and you don't have to put anything else in, okay? If I want to do something like this, it has to be in the begin structure, right? Because if I put it in an end structure, it would be executed after I went through a file. I could do that, but I don't need to, okay? So this whole business of key and colors, like I said, that allows us to go through the contents of the array, okay, and just print these out. Now, these happen to come out in alphabetical order, but my understanding, according to the documentation that I read, is that they could come out in any order. Did yours come out in this order too? Did you get blue, green, red, or is yours come out in a different order? Blue, green, red?
Blue, red, green.
Okay, yeah, see, that's what they said. They said that there's no promise that it's going to come out in any specific order, okay? So I was wondering if other people might get a different order, right? Which is fine, okay? So this is just taking the keys and printing everything out, okay? These are called associative arrays, and they do not maintain order, even if, as you specify them, right? They're not even in the order that we specified them in the definition, okay? All right. Now, it is possible to set up a two-dimensional array. That's another thing that we could do. So that would be, like if you think about the cubbies that we have here, right? What we had initially here was we had 3 cubbies, right, for colors, but it was just them in a line, okay? But we specify with a single index. That's all we need to do. But it is entirely possible to set these things up in a grid, right, where you have something like this, where you have rows and columns, okay? And you could set the matrix up like that, and then you would specify a particular cubby using 2 indices, okay? So we can do that sort of thing now, all right? In fact, let's just do it. This is a simple example that we'll work through, okay? So let's do awk. Okay, begin. Again, we're doing begin. Whoops, begin, right? And then open the curly braces because we now want to do stuff at the beginning, okay? And now we're going to set up, we'll call this thing a matrix, right? And so the first time that we mention it is where it gets defined. And then by specifying with brackets that we have 2 indices, that means, okay, matrix is a 2-dimensional matrix, right? That's what we're doing here, okay? A 2-dimensional array, as you could think of it as a 2-dimensional array. And let's just say we're going to let that first element equal 10, okay? And then let's try this. We have matrix, if I could spell, that would be good. And I'll say 1, 2 is going to equal 20, okay? Matrix 2, 1 is going to equal 30, okay? We separate each of these declarations with semicolons. Bless you. Matrix 2, 2 equals 40, okay? All right. And that is the end of specifying things, but then we can just print things out, okay? So immediately after that, after setting up these definitions, we can do print okay, equals, okay, so I put that in double quotes, right, followed by a comma, and then matrix 1 by 1. 1, 1, right? I'm just going to do 2 of them because I think you guys get the idea here. Matrix 2, 2. Just put that one in. Equals, right? Matrix, comma, sorry. Quote, comma. Yep, got to make sure I get this right. Matrix 2, 2. Okay. And that should do it. It's just going to print out 2 of the elements, not all 4. It's just a little bit too tedious to do it all. Okay. This is not the most efficient way to do this, but it'll work. It should work. So I close the whole thing off with the curly brace because we have to enclose all the things that we're trying to do at the beginning. Okay? And that's all we're going to do. Okay? So I close it off with a single quote. This is just showing you that you can have multiple indices for an array, okay? You can just set this up like this. All right. Okay. So the next thing that I would like to talk to you about is user-defined functions. We've already dealt with functions a little bit. Okay, we have a way to find the length of a string, for example, using a predefined function, but we can also define our own. So let's open up. I gotta make sure, where am I? I'm in my home directory. I'm gonna go to my desktop, and I want to open up Featherpad. Okay, I'm gonna turn the lights down here. Sorry, you guys are back. You're gonna have to mess up. Yeah, that's right. It's still bright white here. Okay, so we got Featherpad open, right? All right, so what we're going to do is set up a function in here that we're going to use to help us with our employee data. Okay, so I'm just going to go back in here to this let me open up the employee data first, because I want to have that open so you can see it. So open, go into the desktop, and I have emp.dat. I want to remember what that is. Okay, so this is what I have in here personally now. I've been fiddling around with it a little bit. I've added a couple of blank lines. You may want to do that yourself, okay, so you get some similar results to mine, so you see what I did. I stuck in a couple of blank lines, and now the file is 8 lines long. Okay, I may change it again, but that's what it is right now. All right, now to write the function, let's say that we want to develop a function that's going to allow us to take the hourly pay, okay, the hourly pay which is in the second field, and round it off. Actually, I think I'm going to take the blank lines out. Sorry about that. I'm being a little bit spontaneous here. Okay, I'm going to open up a new file here where I want to set up a function. Okay, so this is what we're going to do. I'm going to call this function round. Okay, so round, and round is going to take a number. Okay, because that's what you do. You round off a number, right? So I have to tell it to round off something. And the way that I specify what the thing is that I want to round off is I put it inside these parentheses, okay? Then I have to build up the function, what it's going to do. So I open the body of the function. I started off with a curly brace, okay? So here's the idea. I take the number, whatever it is that I'm given, and I add 0.5 to it. Okay? Because think about what happens. If you have something you want to round it off, right? What are you doing? You want it to either round down or round up, depending on what it is, okay? But what I'm going to do here is I then take the value, and I'm going to take the integer part of it. N is equal to the integer part of that number. Okay, so let's think about what will happen. Let's say the number that I pass to it, well, wait a minute, I have to return it. Sorry, I got to return it. This is how we do it. Return N, okay? And then I close off the body of this thing. Okay? And then, after that, print, oh wait, yeah, I'm going to do that. I'm going to do that after. Okay, so this is what I have here, okay? And then after that, in this same file, I'm going to put in print $1, round $2. Okay? The idea being that I'm going to just call this thing a function. Let me give it a very generic name, okay? I'll call it R function, okay? So let's save it as on my desktop. I'm going to call it R function dot AWK. Okay, so it appeared on my desktop. There it is. Okay, so how's this going to work? Let's look at it. If I call it and I give it a number that is, say, 20.1, okay? Actually, you know what we can do? We can call this thing and then just give it different things and see what it does. Let's try that, okay? We can say the following: awk-f function, our function dot awk, okay? And if I do that, and then I don't give it any kind of file to work on, whoops, oh no, I did something wrong. Okay, I don't know what I did. All right, let me just give it the employee data then, because maybe that's the problem. I'm doing this wrong as a result. Nope. Okay, something's not right here. Sorry guys, let me just think about this for a minute.
Apostrophes around it?
No, we don't need to do that when it's inside a file. That's the part that is, I'm not sure what I'm doing. That's not correct here. No, we don't have to put semicolons in when it's inside a file. The fact that each command is on a separate line takes care of that, okay? The thing that's surprising me is that it's not working right. You know what I'm going to do? Maybe we'll do it on the command line and see if that will help, okay? We can try that, because that seems to be working better anyway. So what I'm going to do now is go in here and try the following. We can do awk, whoops, awk begin. All right, I'm going to try to make this a little bit smaller. Okay, and I'll make this one go like that. Okay, begin, and then the stuff that we're going to do in the beginning, okay, are define the function round n. Okay, and then inside we'll put the body of the stuff that we're doing. N is equal to n plus 0.5, semicolon. N is equal to the integer part of n. Take the integer part, and then return n, okay? And then in the body of this awk command, we don't have a pattern that we're searching for. We're just going to pass over all of the employee data. We're going to do print $1, comma, round $2. Okay, and that should do it. Okay, and now it is emp.dat. Nope, not right. Return is outside the function body. Okay, all right. I don't know what my error is here, but I don't want to sort of thrash around trying to figure it out and waste your time on this, so I will figure this out and get back to you about this next week. Okay, we'll just move on from here. We'll just come back to this, all right? Sorry about that. I did get this to work fine a couple of days ago, and I don't remember, you know, looking at my notes, and as far as I can see, I'm following them, but however, it's not working. So let's just move on, okay? Don't worry, we will circle back to this, though, because you do need to know about functions. So that's for next time. Okay. Moving on. We're going to look now at a whole bunch of quick commands that you probably will find useful. And I want to emphasize to you the syntax of awk. And I think I also want you to keep all these things in mind that I'm telling you, because this will help you to prepare for the quiz that you're going to be taking today. Okay? So let's just go through a bunch of things. I'll go over to this now. This is the data that we have that we're working with, and we're going to be working principally with this data that I have here, okay, in this file. So I have it here so that you can refer to it. All right. Let me do clear and start from here. All right. So let's look now. We're going to do awk. We're going to be working with this file. Now, remember how this all works, okay? you can put in begin, right, followed by stuff in curly braces, meaning at the beginning, before you process the files that you're interested in looking at, you do some things, okay? Then you can put in a pattern, right? And then you can put in stuff that you're going to do to the various lines of the file that you process, okay? And then if you want, you can put in more. You can just keep doing this and saying, here's another pattern, okay? So if you detect this pattern in this line that you're in right now, because you're going line by line, do all of these things, okay? If you detect this first pattern, do the stuff in the curly braces that follows right after. If you detect the second pattern, do the stuff in the curly braces that follows right after. Third pattern, do the stuff in the curly braces that follows right after, all to the same line, okay? You can do all that. And then you can have as many of these as you want. Each of the curly braces is optional. If I take out the curly braces here and I just have a pattern, all that you do is you return the line, okay? You print the line that fits the pattern. If all you have is curly braces and no pattern, right? You don't have a pattern that falls before this. That means do the stuff inside these braces to every line, okay? So you can have some number of patterns and curly braces here, and then after that you can have, at the end, when you're all done, you can say, do this stuff, okay? And then you close it out with a single quote, and then you put in the file or files that you want to work on. That's the basic structure of AWK, okay? So, having said that, let's go back and say now we're going to use this AWK command where we're doing something at the end. Okay, that means every single line in whatever file we specify will have been run through. Okay, at the end we say print nr. So what is that going to do? Any ideas? Yeah.
Number of rows.
Yeah, it's number, the R means records, which by default means lines in the file. Okay? Now, if we defined the thing that separated the records in a different way, it could be something else. But the default is the new line symbol is where you break off. So you got a line, and at the end of every line you got a new line symbol, and that's the indicator that, okay, we're done with this record, move on to the next one, move on to the next one. And that's usually what you want to do, okay? But it's not called NL, number of lines, it's called number of records, so that you have the freedom to specify a different record separator, okay? So this particular file that we gave it has 6 lines in it, right? Okay, so that's what it's going to return. Yes?
Could you do the same thing without end?
Let's try that. If we take out end, what's going to happen? It's going to do that operation on every line of the file. And so what you have is NR is a little counter. Every time you go through a line, it increments by 1. Okay? So if all you care about is how many lines there are that you processed, you only say, tell me at the end. But if you want to know as you're going, then you can put that in and have it do it every single line. Right? So putting this in this command with this command here with no pattern right before it means do this to every single line. Okay? All right, that was a good question. All right, here's another one. Let's go back to this. What if we put in this?
Print the last row.
Print row 6.
Will it print row 6?
No, it'll do nothing.
Oh, wait, column 6 and then column 6.
Oh. You got 7.
It's going to try to give you, remember, when you put a $sign in with something right after it, that means field. Okay, and NR is some number, right? So it's going to tell you what's in the 6th field at the end. So what did it print? Why?
Because the 6th field does not exist.
The 6th field doesn't exist. Okay? So let's go back to the one that Sam asked about. This one? Let's put it in here. Okay? What did it do?
You want to look at a diagonal path, is that-
Yeah, so now it executed for every single line. So NR is equal to 1 in the first line, because that's the record number that you're on, right? So what you're asking it to do is print field number 1. Field number 1 is Beth, right? In the second line, NR is equal to 2. So you're asking it to print field 2, 19. In the third line, print field 3. That's 10. In the fourth line, print field 4, blah. In the fifth line, print field 5. There is no field 5. No field 6, okay? So that's the difference between NR and $NR, right? Okay. Okay. Next. AWK. NR less than or equal to 3. So let's look at this thing. You don't see begin or end, right? So what is this thing that we've asked it to do? What is it going to work on? Yeah.
Gonna work on the first 3 records. Our counts 1, 2, 3.
Right. So what we specified here is not inside curly braces, so it's a pattern. Okay. So it's saying, okay, match up all the lines in the file to this pattern. How many of them will match? 3. Which ones? The first 3 lines, because the record number in each of those is 3 or less. In line 1, NR is 1. In line 2, NR is 2. In line 3, NR is 3, right? And if you don't give it any commands, which we didn't do, all it's going to do is print those lines that match. Okay? Pattern matching. If we do this instead, what lines will print now? 3, 4, 5, and 6, right? Because we were saying find the lines where the record number is 3 or higher. Okay? What about this one?
1, 2, 4, 5, 6.
Right, because that means not equal, right? Yep. Okay. All right, now, what about this one? What will this one do? NR does anybody know? Whoops, deleted it, sorry. There it is.
Oh, will that just print the even ones?
Why do you say that?
Oh wait.
I'd say it prints.
Oh wait, no. It prints the odd ones.
Why?
Because it is the remainder divided by 2. And if that leaves at least 1, then it's an odd number. Like 1, remainder is 1. Therefore, it'll print it.
Okay, so that percent sign, what does that do?
What's the remainder?
It returns the remainder of division. Okay, so the number that comes right after the number before the percent sign is the thing that you're going to divide. Okay, the number that comes after the percent sign is the thing you're dividing by. So when you take NR, you divide it by 2. Okay, but it does whole number division, and what it returns is the remainder. So if you're dividing a number by 2 and its remainder is 1, what does it tell you about that number? What kind of number is it? It's an odd number, right? So if you want the odd lines, that's how you get them. Okay? All right. Here's another one. Okay, so now, notice I put the curly braces in. Okay. whoops, I had to put a space in here. I didn't do that. emp.dat. Okay. The commands that we've just dealt with before, the awk commands, they all were patterns, right? They did not have curly braces around them. So when you put in a pattern with nothing coming right after it, all you do is you return the lines that match, right? In this case, instead, we have a command, right? We don't have a pattern at all. So which lines will this apply to? All of them. Yes. I'm sorry I keep saying the same things, but I think it's important to make sure that everybody is very clear on this, okay? So we're going to put in this print statement, okay? And actually, I think we've done this one already, haven't we? Yeah. Nope, maybe not. Okay. We're going to print out, no, we haven't done this one. Okay. What happened here? What did this do?
It prints out the last field.
It prints out the last field. NF is the number of fields. So every line, as it's processed by awk, number of fields is detected. So in this first line here, you see there are 3, right? Second line, there are 4. So that's how you can capture the last field, okay? It's a useful thing to be able to do. All right, what if we do this instead? Take that last command that we had and then put end in front. What's it going to do?
Print the last one.
It'll only print the last one because you do it at the end. At the end, NF still has some value. It does, right? And it works on the last line. Okay. What if we do this instead? What do we get? Nothing. Why?
Because begin happened before you even read the file, so therefore it was
Right.
reading nothing.
Begin executes before you process any files whatsoever. Okay, so you have no value. NF doesn't have any value. So that's why nothing gets returned. Okay? There are things you want to do at the beginning, things you want to do at every line, and things that you want to do at the end. So when you're thinking about what you want to do, you have to figure out where it's supposed to appear in the command. Okay? All right. How about this? awk NF greater than 3. What does that do?
Print bullet in black because those are field 4s, which
Yes.
are greater than 3.
Okay, so the pattern, what you're going to do is filter for lines that have more than 3 records. But there's no command, so all you do is print the whole line in each case. So this one matched the pattern because there were 4 fields. This one matched the pattern. It had 4 fields as well. Okay? All right. Another one. What will that do?
Print all the ones that don't have 4 fields.
Print all of the records that don't have 4 fields. Okay? All right. Another one. Oops, I forgot to put a quote in. Now we're going to deal with $NF, okay? So every line has some number of fields, right? So $NF specifies the last field in the line, right? So what did this do? Yeah, so why do we have in there those first two lines, though?
By
Because those aren't numbers, right? Those are not numbers. It seems strange that these lines that have blip and blah in them got printed, right?
well, because isn't in the system every number and letter considered a character, therefore it has a priority, and all characters are technically a higher number than numbers, so therefore it prints them because.
Well, I looked into that. I thought it might be that, but that's not what it is. It's AWK just doesn't deal with these appropriately. So what you have to do to force it to deal with it appropriately, there's a way you can do it that where you take into consideration that something like this might happen, where the field might not be numerical. Okay, so you can fix it as follows. Okay, you go back in here because I pulled the command back. Okay, and now you just take that value, enclose it in parentheses, and add 0 to it. Okay, and that will force it to act like a number. Okay, now here's what happens. A string, a character string, AWK will consider it to be 0. Okay, but it won't really think about it as a number unless we do something like that as we're testing it. Okay, what we don't want to do is pull up, we don't want it to be that we have lines like this, these first two lines show up because they're not numerical fields. But that prevents non-numerical fields from being considered to have passed this test. Okay, just so you keep that in mind. I mean, these are things like when you're dealing with data, you want to be able to usually make some assumptions about it, what you're dealing with. But on the other hand, sometimes if you're not absolutely certain that what you have is going to be numerical, sometimes you have to do something like this to force it to be dealt with appropriately. Okay. Here's another one. AWK. I'm going to set up a variable that I'm going to call lowercase nf. All right? It's what am I doing in here? I want to count up the number of fields that I have. So I'm a running total of it. So I'm going to use the plus equals shortcut and put in capital NF. Okay, so this is going to be something where I'm counting fields. I go through every line, right? Every single line. I don't have a pattern to filter out any particular line. And I'm saying, okay, let's take the number of fields in this and put it in here into this lowercase nf variable, which is different. Okay, AWK is case sensitive. Okay, so I put that in there, and then at the end, after I've counted them all up, I want to print them out. Whoops. Tell me how many fields there are in this file. Okay, emp.dat. Okay, 20 is what I got. If you count them up, you probably get that, right? There's 3 in every line. There's 6 lines, 18, and then there's 2 lines that have an extra field. That makes 20. Okay, so that's correct. So this nf variable was defined as soon as we started using it. Okay? Alrighty. Okay. Let's do another one. AWK. Yeah.
On that last line,
Yeah.
what is that first in the curly braces? What is that first thing doing?
This here?
Lowercase and then plus equals.
This thing here? Okay. That's I'll put it in again and I'll show you another way to write it. It's a shortcut way to write the following. NF equals NF plus NF. Okay, all you're doing, when you remember what the equal sign does, it's an assignment, right? You're saying, I am taking this variable that I have defined here called lowercase nf, and I want to assign to it the current value plus this new thing that I'm adding onto it. I'm incrementing it by capital NF, the number of fields, okay? Why am I using NF lowercase? Because this is the overall number of fields. I probably should use something else besides NF. That's kind of a confusing variable to use. Let me use something else. I'll call it total NF or something like that because that's more descriptive. Total, I can't get it to edit. I can't edit it, I'm sorry. let's do this again. Okay, awk. It's just that it's nice to use short names, you know. Total NF equals total NF plus NF. Okay? So that's just a shortcut way to do it. I'll put it in again with the shortcut way. No, that's not it, but that's all right. Just put it in here like this. Total NF plus equals NF. So it's just saying take total NF and increment it by NF. It means the same thing as this above. Okay, this that I have highlighted is equivalent to what's below it in the curly brackets. Okay, it's just because that kind of thing is that kind of assignment is very, very common. And so it's shorter to write it this way. It's a little more cryptic, but it's more compact. Okay. All right. So that will get us the same thing. All right. All right. Let me see what else we can do here. Just do a few more. Okay. Let's do this. Awk, and then we're going to look at field 2 greater than a variable that I'm defining to be called max. Okay, I haven't specified what max is yet. You can tell it's a number though because of the way that I'm using it, right? With a greater than symbol. The first time I mention it and it's clear that it's a number, it's assigned the value of 0 unless I say otherwise. Okay, so this is the thing I'm using to filter. Okay, we'll talk about what this all means in a minute. All right, so I'm saying if what I have in field 2, you remember what field 2 is? Field 2 is the hourly wage. If the hourly wage is greater than whatever max's value is, then I'm going to do the stuff that appears in the curly braces. Okay, so what's in the curly braces? Well, I'm going to give max a new value, $2. Okay, the second field. So the very first line I read in, I know that this field 2 is greater than 0. So that's going to be the new value of max, okay? And the line that contains that new maximum value of hourly wage is the current line. Okay, the current line, $0. All right? So what I'm going to do is I'm going to go through this file one line at a time, and I'm going to check to see what's in field 2. If what I see in field 2 is larger than the previous value, which is being stored in max, then I'll make that the new max. I'm trying to determine who is making the most money here per hour. Okay, that's what this is about. Okay, and then I also keep in max line, I keep all the information that's in the line. All right. So once I do that, at the end, after I've completed going through the file, then I want to print what that maximum is, okay? I'm going to print out max and what max line is. Tell me what the maximum is, amount of money that is being made, the hourly wage of these employees, and then print the entire line. Okay, so it turns out, you can see by inspection looking at the file, that Mark has the highest hourly wage, right? And then I print the whole line after that. Okay, let's go back to this file, and remember I told you I had those blank lines, and I'm going to put them in now. Just stick a couple of blank lines in and save it. All right, and now what we want to do is awk, and we want to, the filter that we're going to use is the number of fields is positive. Okay, so print out the lines from the field, or from the file that have at least one field. Okay, so it didn't print all the lines. I included a couple of extra lines in here that are blank, right? It filtered those out. Okay, another one. Awk. Remember I was talking about the length function. The length function. Let's say I'm going to take the length of the whole line, okay? And if it's greater than 12, I want to print that. Okay, that's the filter that I'm using. Okay, so any line that has at least 12 characters long gets printed out. This one's pretty straightforward, I think. Bless you. For every line, I want to print the first two fields, and I want to print them in reverse order. Okay. Okay, so it just takes all these lines, including the blank ones that I had in there. Okay, just it flips them. Now, there's another way that we can do this, where we can do something a little bit more complex. You know, I might want to do something. This is basically going to do the same thing, but this is allowing you to use these variables in other ways, and we're not going to do that in this particular case, but just to see what you could do. I could set up a variable I'm going to call temp, and I can assign to it the value of what's in the first field. And then the first field, I'm going to throw in there what's in the second field, and then the second field is going to take what's in temp. Okay, so it's just switching them around in this way. Okay, and then if I wanted to, I could do more, but for now I'm just going to print. Okay, I'm going to print the line. Okay, so it prints out the whole line and it reverses the first two fields. Now, as I said, that's all we did here in these instructions, and the last thing we did was print, but we could have done more. It's just you can use these variables internally within the command, like in the command, and you can do more to it, more processing if you want. Okay, here's another one. Let's say I want to remove the contents of the second field. Okay, I can do that, right? And I can print out what I've got. Okay, I'm doing this to every line because there is no pattern. Whoops, I have to close that out with a close quote, emp.dat. Okay, there we go. So you no longer see the second field. All right. Now here's one. We can print in reverse order the fields of every line. AWK, okay? So since we're doing it to every line, we don't have to put a pattern in, but in order to do this for every line, we're going to use a for loop. Now, with the for loop, you have to specify stuff in parentheses, okay? There are three things you have to do. The first thing is to take the variable, we're going to use the index and assign it a value. It's going to be the number of fields, okay? Remember, this is happening in every single line, okay? And the test you're going to make is I greater than 0, okay? As you loop through. That's the thing you're going to check. As long as I is greater than 0, you're going to continue to execute the loop. But then you have to have some kind of increment, okay? It doesn't have to be an increment. It could be a decrement. The decrement that we're using, we're going to count down, okay? I minus minus means subtract 1 every time you go through the loop. So you're going to go and check to see how many fields there are in a given line. And then you're going to decrement through them. Let's say there are 3 fields in the line. It's going to execute the loop. You're going to count down 3, 2, 1, and then when you get to 0, you're going to stop, okay? So that's setting up the for loop to operate in that way. And then what are you going to actually do while you're inside the for loop? Okay, I'm going to put curly brace here. You're going to do print f. Okay, and then inside we have some formatting, and it's going to be percent. Where's the percent sign? Here we go. Percent s, and then a space, and then $i. Okay. So it's whatever field number you're at, okay? And then a semicolon, okay? And then we have to do another print statement. Print f, we have to put in a new line symbol. Oops, we put it in like this. Okay, and close it in double quotes like that. Okay. All right, so I have to put in one more curly brace to make sure that we have balance here. Okay, so what do we have here? I'll put the close quote. We have this inner set of curly braces is what you do inside the for loop. Okay, it's 2 print statements. Then you have the outer curly brace that is what you're going to do to every single line. All the stuff that's enclosed in there. All right? And then we apply this to emp.dat. Oh, no. All right. What did I do wrong? Oh, okay. I think I left out a comma here. It's supposed to be a comma here. Try that. Yeah, that worked. Okay, I'll bring it back so you can see it.
Why do we need a second print statement for the new line character?
Very good question. I looked it up because I was wondering the same thing myself as I was working through this example. It has to do with the way printf behaves. This \n, because I would want to put it after the I, it can't stand alone within the printf statement here. It's a strange thing. Okay? The printf doesn't automatically put in a new line symbol. Print does, but printf does not.
I mean, can we do %s space \n?
You could try doing that, yeah. We could.
I get the same thing.
Yeah. Okay. It's just it's a oddness thing about this. That's another thing about awk that is kind of an odd thing. Let me just put this in again. Okay. All right. I think we're just going to do a couple more of these things and then knock off for today. Yeah, we got to finish up. All right. Okay. Let's do this. Awk. We're going to print the sums of the fields of every line. Okay? So we're going to set up a variable called sum. We're going to let it equal 0. Okay? And then have a for loop. For I is equal to 1. This thing we're going to use our index. While I is less than or equal to the number of fields. Oops. We're going to increment I. Okay? In every loop. Okay, and then sum equals sum plus $i. Print sum. Let me just make sure this is going to work. According to my notes, it should work. Oh, I need some numbers, though. Yeah, this isn't going to work unless we have some numbers. So let's get some numbers together, okay? Let's do new. One, two, three, 4.
It works on empty data.
It does, but it has strings in there, right?
Yeah.
So what does it do with the strings?
Ignores them.
It ignores them? Okay. We can do that then. Let's just do that because we already have that ready to go. Okay, let's do emp.data, emp. Okay, so it adds up the numbers that you have in the fields. Okay, the numerical ones. So including the blank lines where it gives you 0. Okay. All right. I think that just practice with awk is helpful. I hope that this has helped you to see a little bit better how it works. The whole point of us working with sed and awk and so forth is to help you so that you'll be able to collect and analyze data, okay, which we're going to be doing more of once we get going even more. This is just like laying out the tools and having you work and play around with the tools for a little while before we dive into that. All right, so I am going to stop.